according to what we did yesterday, we said the y-intercept over there, the y-intercept over there, it's a negative value. It's a negative value. That's what we said. And that negative value, it is the work function. That is the work function over there. And then we said the x-intercept over here, the x-intercept, that is your what? That is your threshold frequency. Threshold, the spelling just flied away. Whatever, threshold frequency over there, which means that is the minimum frequency needed to eject the electrons from the metal surface over there. Then now, that's the two important things you need to know from your graph. And you also need to know the gradient, or what does the gradient represent? Because according to what we did yesterday, we said I have E is equal to WO plus EK. All right. And then I asked myself, what is my y-intercept? My y-intercept represents the EK. Okay. So according to a straight line formula, it says y is equal to mx plus c. And then this y, it is my EK over there, which means I'm going to write EK just like that. Then now, what you will see is that we also have the work function over here. The work function, and work function is represented. Oh, another thing, you're going to ask yourself, what is your x-axis? Your x-axis. Oh, did I say? Okay, your x-axis has the what? Has the frequency. That is your x-axis. On the x, you have the frequency. So your frequency represents your value of x. This x is a frequency in this case. And then this m is a gradient, is a constant value that doesn't change. The only constant value that we have here, it is Planck's constant, which is 6.63 times 10 to the power negative 34. So which means here I'm going to have my h, which is a constant. And then here I have my f like that. Yes, my f like that. As I took, oh, that one is for image. This one is for image. Then we said on our y-intercept, our y-intercept is the work function. So which means I'm going to have negative WO. Because don't forget that C, according to a straight line graph, C represents the y-intercept. Yes, it represents the y-intercept. And then here, WO is our C over there. So that's how it is, which means this one is our gradient. This one is our y-axis, our x-axis, our y-intercept over there. That's what you need to understand and know. Then from there, the second question says, give a reason why no photoelectrons are released when light of 45 times 10 to the power negative 40 hertz is used. So starting here, we have a 50. Then over here, we have something like 45. That is almost like 45. This is where the frequency of 45 is. So now don't forget that electrons will start to be emitted. The electrons are going to start to be emitted at this point, at the threshold frequency. They will start to be emitted at the threshold frequency. So anything before 50, anything before 50 will not release any electron, because that frequency is not sufficient enough to remove the electrons from the metal surface. It becomes sufficient on the threshold frequency, the minimum frequency needed to remove electrons from the metal surface. and which is at the 50 over there. So the reason that you can give here is an open-ended. You have to give according to your understanding. What you can say, give a reason why no electrons will be released when light off is used. You can say that frequency is less than the threshold frequency. They want a reason. So for me, I was just going to say F is less than FO, which means that frequency they've given me, the frequency given is less than the threshold frequency. And then you get your 2 marks. Because don't forget that in our first lesson, we said that no electrons will be emitted if the energy used is less than the work function, or if the frequency used is less than the threshold frequency over there. Then they said which quantity can be determined from the gradient of the graph. A straight line graph always has a constant graph from mathematics. So which means the quantity that can be determined, that quantity is Planck's. I don't know if the spelling is correct. Planck, something like Planck's, something like this. Constant. That is the quantity that can be determined from the gradient. Because this Planck's constant is 6.63 times 10 to the power negative 34, of which it is your age over there. I hope you're not falling asleep just yet. You still have a long way to go. A long way. Now, the following question says, okay, the fourth question says, calculate the magnitude of x. They want you to calculate the work function. How do you calculate the work function again? In order to calculate the work function, you say WO is equal to HFO. WO is equal to HFO. FO over there like this. Then what is your Planck's constant? That is 6.63 times 10 to the power negative 34. And then what is your threshold frequency? That is 50 times 10 to the power what? To the power 14. So can you multiply this on your calculator and give me the answer? What is 6.63 times 10 to the power negative 34 multiplied by 50 times 10 to the power negative times 10 to the power 14? That's 50 times 10 to the power 14.
3,32 times 10 to the power 18.
The power 18. That is your work function joules over there.
18.
Oh, to the power 18 or 15?
It's 18.
Oh, negative 18. Sorry about that. Negative 18 joules. I was still wondering why it came back as a positive value. And I just realized that the question said calculate the magnitude. Magnitude. So that's why the value came back as positive. Because it's here, it was supposed to be negative something, but it's fine. Came back as positive because they want the magnitude only. Like that. So that's your work function. It doesn't change unless if we change the matter. Then the second question says light of frequency 110 times 10 to the power 14 is shown onto the metal. Calculate the speed of ejected electrons. So in order to calculate the speed, you're going to do the same procedure. You're going to use the formula E is equal to H, or E is equal to W O plus EQ over there. And then for energy, in terms of the energy, you have the frequency. So on this side, you are going to say 6,63 times 10 to the power negative 34 multiplied by your frequency, which is 110 times 10 to the power 40. Then what is the work function? The work function we just calculated above. That's your work function, 3.32 times 10 to the power negative 18. That is your work function, 3.32 times 10 to the power negative 18 over there. Plus, what is it that you're looking for? You're looking for the speed, of which you're going to say 1 over 2, 9.11 times 10 to the power negative 31 multiplied by v squared over there. So what you can do, you can multiply this and then subtract that one from your calculator. And then you will tell me the answer.